Hi guys, welcome back to my channel. This is the second episode of the series on fixed income finance, starting with a look at very basic concepts around interest. And again, savings is a good place to start because everybody can relate to it. And I want to kind of try and demystify some of the questions that people might have about how the interest is actually calculated in their own bank accounts. Because to me, I saw, okay, why do I get paid more interest in 1 month and less in the next month? And I always wondered things like, oh, does it, do I get paid interest for weekends and bank holidays, and lots of silly questions like that. But ultimately, I always felt like there was a bit of kind of randomness going on, and that I wouldn't be able to actually check what exactly the banker is saying I'm due in my statement. So I had a look around, building on the concepts that we talked about in the first video around compounding. I actually took an example of an actual 1 month statement of my own bank account. It's my cash ISA. The numbers are authentic. My account details are not there, but that is basically a real life example which I'm going to walk you through step by step and show you exactly how the interest is calculated. I'm also going to introduce the concept of AER. We're going to touch on monthly compounding, which we talked about the first time, because this example, the account that I'm talking about is a monthly compounding account, which means that the interest is paid once a month on the 27th of the month. So a key point here is in the examples in the first video, they were very simple. You invest in an initial principal, and then you hold it constant, or you leave it with the borrower for n number of periods, and it compounds over that time. The obvious complication with banks is that you're taking money out all the time, putting money in all the time. So you can't the calculation becomes a lot more complicated then. And that's what always made me think, how on earth does it actually work? So I'm going to explain that. Even things like rounding, right? Just to get that level of comfort. Remember I said what I want this series to be about is, there should be no detail that's too kind of fine-grained. And we want full 100% confidence in the numbers. So even stuff like rounding, do they round it up? Do they round it down? All that kind of stuff. And also timing. Maybe I'm the only person who asks these questions, but if I basically deposit some money in the morning in my bank and it's in the account by 10 o'clock, do I get more interest than if I just managed to get it in before closing? Or what are the deadlines, etc. Essentially for, and how do they influence the calculation? So that's a bit of a kind of an introduction. So I want to talk about AER briefly. So AER stands for annual equivalent rate, right? And it's simply when an interest rate R is quoted as an annual rate, and it compounds, let's say, over n periods within the year. So let's say n equals 12 for monthly compounding, or n would equal 4 for quarterly compounding. When that happens, obviously the AER is the interest rate that will give you the equivalent yield, the equivalent final balance after 1 year, as if there's only one payment at the end of the year, right? So let me just illustrate it with an example here. So we're saying, so for our compounding, right, we have our initial investment, and then we have 1 plus R over n to the power n. This is our final balance after 1 year, right, where n is the number of compounding periods within the year. So n could be 12 for monthly, right? And we're saying, what is the interest rate, called the AER, the annual equivalent rate, that would give me exactly the same final amount, but in return for my exactly the same initial amount, but only paying once at the end of the year. right? Not paying every month or every 3 months, no compounding in the middle. So in that scenario, if I invest P0 and the interest payment is annually, and my interest rate is the AER, then my return after 1 year is P0 times 1 plus AER, right? So we basically solve these guys and say, well, rearrange and find out what AER is, because AER is a function of the nominal interest rate and the compounding periods. And if we rearrange, we find, so 1 plus R over N equals 1 plus AER. I said this was going to be from the basics. I didn't lie. So basically, sorry, that's to the N. So we have AER, annual effective rate, equals 1 plus R over N to the power N minus 1, right? And you can see in my example, in my my actual bank account down here, so the rate, the nominal interest rate for the year is 0.0159, so 1.59%, and the AER is 1.6. And if you plug in the numbers here, so N equals 12, and if you plug in R equals 1.59%, then this comes out at 1.6, which is the actual quoted AER on my bank account. So, so basically, this on the left-hand side here, this is actually my my ISA, right? So the numbers are genuine, and I copied them right out of the bank statement, because I really wanted to kind of understand the nitty-gritty of what goes into this calculation. Okay, so I want to take you through it. It's just 1 month. It looks a bit, spreadsheets are not the most exciting thing in the world for everybody, but I think it is nice to see a kind of a real world example and see it all kind of pan out in front of your very eyes. So the basics of this account, and I've written them down here. So the rate, which is the interest rate down here, is 0.0159. So R equals 1.59%. Days in the year is 365. It normally is 365. Obviously, in a leap year, the days in the year are 366. Now, this is actually important in the field of fixed income finance, and in my next video, I'm actually going to talk about day count conventions. So day count convention is a standard and a set of conventions that define how things like leap years and let's say the number of days in a month, because the number of days in a month is different from month to month, how those impact more complex financial calculations. So in my next video, I'm going to go into that, because it's actually a very useful thing to kind of have a basic grasp of. But this account, 2015 was a year in which there were 365 days in the year. AER, as we've already discussed, was 1.6. That's not actually part of this calculation. Compounding periods is 12, right? So N equals 12. So we have monthly payments. Okay. Now we're going from the start of the period, which is, so the first day of the period is the 27th of March. Okay, and as I said, this is a monthly paying account. Now, pay attention with me. I'm assuming if you're watching this video, it's because you really want to understand it. So yeah, I might end up repeating myself, but this account, it pays on the 27th of the month, right? Every month, right? 12 payments in a year. Now, let's go into one of the first questions I was wondering, which is basically, how is the interest actually calculated in a bank scenario? Because I put money in the bank, I take money out all the time. So this kind of whole simple 1 plus R to the N type thing is not going to apply, because this P0, this P is changing all the time, right? So clearly it's going to be a bit more complicated than that. It's related to that, but it's a bit more complicated. Now, in a nutshell, the key to it is that interest in the savings account is calculated every day. Right? Every single day the interest is calculated. And what is the interest calculated based on? It's based on the closing balance. Right? Really important. Not the balance at the beginning of the day. The balance can change at various times in the day. I can take money out. If it reflects straight away, then my balance will go down. Every day at close of business, in whatever bank, in whichever country you're banking in, there will be a closing balance of that account, right? And that closing balance feeds into the interest calculation for that day. Okay? That's really, really, really important. Okay? So the question is, well, what is that calculation then? What is calculated every day? Okay, so let's go. So we go to the top row here, and we see that for the first few days of this period, from the 27th, 28th, 29th, 30th, the first 11 days, the start balance and the closing balance on each day are identical, right? There's no activity on the account whatsoever. There's no interest being paid because interest is paid on the 27th, so we're not getting interest paid until the next 27th. So each day you can see that we have 1 day of accrued interest, but it's not paid into the account. It's just kept sort of conceptually. It's kept in a kind of a side pot until the 27th. Okay, but let's have a look at what this calculation is. It's basically it's the balance, the closing balance, C3, closing balance at the end of the day, multiplied by B41, which is the interest rate, divided by B42, which is the number of days in the year. Interesting. So, actually, what we're saying is the daily interest equals P, right? The closing balance on it, let's say P daily, or let's call it P close. P close multiplied by R over 3, 6, 5. Daily interest. So what we're actually doing is saying, because normally if we just say, okay, do you know what, the balance is going, the P is staying fixed throughout the year, so every month I just basically divide R, right, up into 12 chunks, right, so R divided by 12, and then once a month I make a payment with that amount, and then that that compounds month by month. That's a simple example that we were looking at in the first session. So that's where we say kind of 1 plus R over 12 times 1 plus R over 12. That's a sort of simplified example, because in the sense that's not going to work here. We have a balance P that's changing every day, so we have to calculate the interest from scratch every day. So instead of dividing R by 12 and applying the interest every month, we have to divide R by 365, apply that to the granular closing balance of that particular day, and then keep that amount of money in a side pot until we actually pay the balance, right? So this is actually just to hammer the point home. What we're doing here is we're calculating daily, but we're paying and compounding monthly. And the first time I saw this, I found it a bit difficult to get my head around. But ultimately, so after day one, the amount of interest that you've earned is basically P close day 1 times R over 365, right? And the amount of interest you've earned after day 2 is that, okay, plus P close day 2 times R over 365. And that's the way it goes during the month. So you can see, so this is over here, this is our kind of accrued interest each day, and it's identical because the closing balance is identical in the first 11 days, okay? And we get down to the first time we see anything interesting is on the 7th of April, right? And this is very interesting. So basically, on the 7th of April, I paid £240 into my account, right? So £240 goes into the account. So you can see that the start balance was this, same as the day before, but the end balance, because I managed to get that payment in time for the end balance, the closing balance on that day is £240 higher, and therefore the accrued for that day, right, which again is basically my P close times R over 365. That's higher today because now it's being applied on the extra £240. Then what happened the next day is I paid some more money in, right? So I paid some more money on the next day, and the closing balance went up again, right, to this new number, and subsequently that new close balance was higher again, right? And so the accrued interest basically stayed at this higher level per day, and until we get to the 27th, again the daily calculation stays the same, right? So that's a key point. Interest is calculated daily based on what the closing balance of that day, because the closing balance goes up and down, using the nominal interest rate on the account divided by 365, or however many days there are in that year, and then it will basically keep that, it keeps these individual numbers, these calculations, in a kind of a side pot until, and you can see over here I've got a cumulative column here, so the cumulative is basically just the cumulative sum of all these values as we go through the month, right? And we see that by the time we get to the closing balance of the 26th, right, the closing balance of the 26th, right, we have basically got £103 of interest, £103.43. That's the total amount of interest accumulated from these daily calculations since the last 27th, right? Now, this is really important. That is the amount that we've accumulated so far, but it's paid, right, on the 27th. So it's not, we don't get that money until the 27th, and we see the way it's done is it's added to the end balance down here, right? So the closing balance, right, the closing balance on the 27th includes the £103.43 interest, right? And more to the point, you can see that the accrued interest that is part of the calculation for the 27th, right, is slightly higher. It's now 3.97 versus 3.93, right? So it's a really important point just to hammer it home. So the interest, it accrues up until the 26th, this is for this period, it gets paid on the 27th, included in the closing balance for the 27th, and therefore the first accrued interest amount for the next period is slightly higher than before, right? So that's basically how the interest for that period was calculated, right? And that's really how it accrues. So we pay monthly, but we calculate the actual the interest on a daily basis. So one thing I want to sort of to point out was that I said that the number of days in the year is 365, and so just to sort of introduce the concept of day count convention. So basically, if we had let's say we had a leap year, okay, and let's say I'm just going to sort of, because I said we're not going to skip over any details, and I'll go into more detail next time. But let's say this new year is a leap year, and then this is 1st of Jan, and this is a non-leap year, right? And let's say this was the 27th of December, and this is the 27th of Jan. Okay, so clearly in this period, the first few days fall in a non-leap year, and then the remaining few days of that period fall within the leap year. So in that case, the calculation becomes slightly more complicated because, but again, it depends on what day count convention that the banks are using. So just to give you a flavour, in the next video I'm going to go into more detail about day count conventions. But that's really that in terms of this small calculation. And in summary, the interest is paid on the 27th. That interest becomes part of the closing balance in the account on the 27th. The interest is basically made up of a pool of all of the accrued interest calculations starting from the previous 27th, and the last entry into that pool is the calculation for the 26th. The next day, the first entry in the new period pool is the accrued interest calculation for the 27th, which includes the payment of the previous pool from the previous period, right? So if you've got any questions on that, just let me know. I know it's not that straightforward, but I hope I've hope you can sort of look at the numbers, maybe have a look at your own bank accounts, and make sure the banks are not swindling you. So as I said, in the next video I'm going to go into more on day count conventions, and thanks for watching. All right, bye.